Good morning students, welcome to 8th video on system of particles and rotational motion. So in this video we are going to know equilibrium condition of a rigid body and the concept of couple and moment of couple. Let us know what is equilibrium condition of a rigid body. We know that rigid body is one which is consists of large number of interacting particles which is capable of rotating with respect to an axis in rotational motion. Now we want to know what is the condition of equilibrium of a rigid body, or when does a rigid body is considered to be under equilibrium condition. So in order to have a rigid body under equilibrium condition, we must satisfy both the condition, that is translational equilibrium as well as rotational equilibrium. So let me know first condition for translational equilibrium. So a rigid body is under mechanical equilibrium if it is under translational equilibrium as well as rotational equilibrium. So we will write the condition for translational equilibrium in vector F1, vector F2, so on vector F1 are the forces on a rigid body. Then condition for translational equilibrium is then vector sum of all the forces acting on the rigid body. Rigid body is 0. So this is condition for translational equilibrium. If F1, F2, etc., Fn are the forces on the rigid body, then vector sum of all the forces acting on the rigid body is 0. That is vector F1 plus vector F2 plus so on plus vector Fn should be equal to 0. So R, we take summation of I is equal to 1 to n of vector Fy should be equal to 0. This is the condition of translational equilibrium of a rigid body. But as this is a rigid body capable of rotating about an axis, the condition of mechanical equilibrium says that the body is under mechanical equilibrium when both translational as well as rotational equilibrium. So let us know what is the condition for rotational equilibrium. If tau 1, tau 2, etc., tau n are the torque on the rigid body, that is individual torque acting on the system of particles of the rigid body, then condition for rotational equilibrium is the vector sum of all the torques acting on the rigid body is 0. Vector sum of forces as well as vector sum of torque acting on the rigid body is 0. Then we call that as body is under mechanical equilibrium. So that is vector tau 1 plus vector tau 2 plus so on plus vector tau n will be equal to 0. Or other words, summation of I is equal to 1 to n of vector tau I will be equal to 0. This is the condition for rotational equilibrium and this is the condition for translational equilibrium. When both these conditions are satisfied, then we say that body is under mechanical equilibrium. This may ask for 2 marks. That is, write the condition for mechanical equilibrium of a rigid body. Then you have to write both the conditions. A rigid body is under mechanical equilibrium if it possesses both translational equilibrium as well as rotational equilibrium. That is, you write only this condition. Summation of I is equal to 1 to n of fi is equal to 0 and summation of I is equal to 1 to n of tau I is equal to 0. So this is the condition of equilibrium of a rigid body. So now let us know what is couple and movement of couple. Couple means two equal and opposite forces with a different line of action of force constitute a couple. Two equal and opposite forces with different line of action of force. Line of action of force constitute couple. So two equal and opposite forces with a different line of action of force acting on a body constitute couple. For example, if you are having two equal and opposite forces which are represented by like this. So this is minus F and this is plus F force. These two are the equal and opposite forces because this force acts downward and this force acts upward. Therefore these two are two equal and opposite forces with a different line of action of force. That means line of action of force is here of this force which is at A and the line of action of force of this is here which is at B. That means if these two forces are acting at the same point, same A in opposite direction, we know that net force is 0. But in this case net force is non-zero because these two forces are having different action of force. So this force will try to pull this object in this direction or a rigid body in this direction. At the same time, this force will push this rigid body in this direction, which means with respect to this point, if you call this as axis of rotation, if it is a rigid body, then it is going to rotate in this direction. That is, it rotates in anti-clockwise direction in this case. Suppose if this force is upward and this force is downward, then the body rotates in clockwise direction. So which means couple always gives a pure rotational motion in a body. So it won't give any translational motion. When couple acts on the body, it gives pure rotational motion. So thus couple always gives pure rotational motion in a rigid body. See, for example, if I want to open the lid of this bottle, then I have to apply couple, not force. That means if I hold these two fingers to open the lid of this bottle, then thumb will push this lid of the bottle in one direction and the forefinger again pull this lid of the bottle in the other direction so that this bottle lid is going to be opened like this. While closing the lid or opening the lid of a bottle, we apply couple, which gives pure rotational motion. While pedaling the pedal of the bicycle, so we use couple. See, one pedal will, one leg will push one pedal in one direction and other will pull like this. So this is what pure rotational motion constituted by two equal and opposite forces with a different line of action of force, which constitute a couple. So now we want to know movement of couple. Movement of couple. The sum of the moments of these forces is called as couple. Movement of couple is defined as the sum of moments of two forces. Moments of two forces making a couple. So here these two forces are making the couple. The movement of couple is defined as the sum of the moments of two forces. Sum of the moments of two forces means the perpendicular distance into force plus perpendicular distance, this distance into this force, which constitute to the moment of couple. Thus, moment of couple is defined as movement of the sum of the moments of two forces making a couple. Sum of the moment of two forces means force into distance plus force, this force into this distance. Those sum will give moment of couple. So again in this example, if I take F and F dash are the two forces, is if F vector F and vector minus F are the two forces acting at points A and B, which are represented by position vector, we say R1 and R2. R1 and R2 are the position vectors which are pointing the points A and B with the two forces minus F and F. Then movement of couple is right here. Then movement of couple is, we write movement of couple is equal to this force into distance minus F into R1. R1 is the perpendicular distance from this point plus distance, perpendicular distance, line of action of force, this distance into this force F into R2 or R2 into F force. So this implies movement of couple is equal to We take this as R2 minus R1. You can take minus here. Equal to vector R2 minus R1. This into F. Because magnitude of these two forces are same. So we can write that as R2 minus R1 is equal to F. So if this is R2 vector, this is R1 vector, then R2 minus R1 is this distance AB. Therefore, moment of bubble is equal to R2 minus R1 is AB. So that is AB vector cross F. So this is the expression for moment of